In this lecture, we will be discussing aggregate functions, the group by, and having clauses. The aggregate functions in SQL Server are min, max, count, average, and sum. These functions return one result per group of rows processed. These can be thought of as multi-row or group functions. So if we think about these functions, if we want to know the min of something, it makes the most sense to have more than one item. Yes, we could get the min of one value, but that doesn't really make a whole lot of sense. So these functions require us to have a group or a set of records to use them against. For our functions, all of them ignore null values except for count star, which we will talk about a little bit later. And if we need to suppress duplicate values for any of these, we can use the distinct keyword with the functions. The average function calculates the average numeric values for a specific column in our group of rows. It must be a numeric data type, and we ignore nulls. So let's go ahead and do some examples with that. I've got SQL Server connected. I'm going to bump up the size just a little bit. And I'm in my Northwind Traders database. So if I want to do an average of something, let's figure out the average unit price of all of our products. So to select from products P, the average unit price. And when I run this, I will get one result. This is the average unit price for all records in this table. So it takes all the unit prices for all of the products and does an average. When it does this average, it comes out to a number with 4 decimal points. So if we want to clean that up and make that look a little bit nicer, we can change the data type here with a cast. We can cast this as a numeric, and I'm going to do a 5-2 data type that allows for only 2 decimal places. And I can give this an alias too, which makes a little bit more sense. So the average unit price is $28.74. I also have the sum function. So this calculates the sum or the total across a specific group of rows. It must be a numeric data type as well, and again, null values are ignored. So if I wanted to know the sum of all the unit prices, not that that makes a whole lot of sense, but we could do that. Select from products P, sum unit price. So if I bought one of every product, it would cost me $2,241.46. Max function. So max will return the highest value in whatever column you select across the group. Typically we use this with numbers when we think about it, but we can also use it with dates and strings. And min is the same way, so we'll use these together. So min returns the smallest value. If I want to know the cost of the most expensive, most and least expensive products, I can do that. So select from products P, min unit price. So this is least expensive. Max unit price, most expensive. And across our whole table, all of our products, the least expensive one costs $2.50, and the most expensive one costs $263.50. So let's do an example with dates and with strings as well. So if I want to know the first order date and the last order date, I can do that as well. Select from orders O, be it the min order date. That's the first one. It's the smallest value. Do the max order date. That's the most recent one. So the first order was July 4th, 2013, and the most recent one was July 4th, 2015. With strings, I could use this to find the largest last name or the last name alphabetically of an employee, or the first last name alphabetically for an employee. So this calculates it based on the character values. So select from employees E, min last name, max last name. So Bozer is the first one alphabetically, and Suyama is the last one alphabetically. So our count function, this counts records. There are two ways we can use this. We can count non-null values. We can count total records, including nulls. We can also count distinct values. So let's go ahead and do some of that. So sticking with my employees now, how many active employees are there at NW Traders? So select from employees E, put star here for now, and I need a where clause to make sure they're active, where termination date is null. I want to count. So here I could either count a column that isn't null, so the primary key would be a good option. I could count the employee ID, or I could count star. Those should give me the same counts. We have 19 active employees. However, if I were to pick a column that has null values, so if I count the termination date, which we know is null for these people, that gives me 0 because count will ignore nulls. So use any column that does not contain nulls, or use star. So if I want to know how many terminated employees there are, we could do this two ways. So way 1, we could do select count star, count the records from employees, E, where the termination date is not null, and that should give me my 3 terminated employees. Or I could count the termination dates. Select count, go back to that, from employees E. So if I count the termination date, it will only count the records that have values, and I still get 3. So way 2, this will ignore records where there is no termination date. So if I want to know a unique count, we can count the unique customers who have orders. So count unique customers with orders. Select from orders O. So if I were to just count the customer IDs in orders, this gives me actually the total number of orders placed. Because it's going to count each instance of that customer ID in the orders table, which equates to one order. If I want to know actually how many customers have orders, I want to count the distinct customer IDs. So it will only count each customer once, regardless of how many orders they have. So 831 orders, but only 90 different customers. So those are our aggregate functions. Without using any additional clauses of our SQL statement, there's not too much we can do with these. We can ask some questions like how many people have been terminated. So we can use where clauses with them. But we can't display a lot of other things until we add some of our other clauses. So back to our select clause syntax. We've gone over the select clause, the from clause, the where clause, and the order by clauses all to this point. Today we're also going to discuss the group by and having clauses. These allow us to do additional things with our aggregate functions. So first, the group by clause. This is used to create groups within our data, and it essentially sets the scope for the aggregate functions. So the function is applied for each group of rows that we create. When we use the group by clause, if we select a column, it either has to be in an aggregate function, or we have to list it in the group by clause, or we're going to get errors. That's a lot easier to demonstrate than it is to say, so we'll go through that. So if I wanted to know something like the count of products by category, I want to select from products, P, and let's include the category name here. So join categories C on the product IDs, sorry, the category IDs. And I'd like to see the category name and a count of the products. If I try to do this without adding any additional clauses, and I run this, I'm going to get an error that tells me category name is invalid in my select list because it's not in an aggregate function or in the group by clause. So as you start writing these, you're probably going to get this error a lot. When we see this, we have to decide something. We have to decide if we need to see this column that it's telling us we have an error on. In this case, if I want to show the categories and their count of products, I absolutely need to see this. So that means I have to put it in my group by clause. So if I run this, now I see each category and how many products we have in it. So a common error with this was 1 for getting our group by clause. So that would cause that error. Another error, including too much data in the select clause. So if I were to come in here and also include my product name, and if I have my group by category name still, when I run this, I'm going to get that same error, but about the product name. So if I try to put my product name in my group by clause, we're going to see something interesting happen. So now, instead of seeing each category and the count of items in the category, we see each category and a product and a count of 1 for everything. So what happens with this group by clause is this count function works for the combination of items in my group by. So for each category and product, it's going to count the product ID. In this case, each product is unique, so my count is always 1. So to fix this, I would have to remove my product name. So in SQL Server, we can't get both the details, so what products are in the category, and an accurate count in the same query yet. We could do this later on. It still isn't as pretty as what we would be able to do in Access. So if we want to see detail and counts, or sums, or averages, we would need to write a query that does the details, and then go to Access and include those counts, sums, or averages. So, count of products by category is an easy one. We could also do we could also answer the question, how many unique products has each customer purchased? So for this, I need my customers, I need my orders, I need order details, and I need products. Well, arguably, we could ignore products because we could get the product ID in the order details table, but you could go to products if you wanted. So, but at a bare minimum, we need the customers table, the orders table, and the order details table for this. Let's get that joined up first. So when we have questions like this, we have to start with our from clause and join all of our tables first. Then we can work on the other parts of this. And in this case, I'm going to left outer join to orders because I want to see my customers even if they don't have any products, because the unique products they've ordered is 0. So left outer join orders O. This is on the customer IDs. And then I have to left outer join to order details because I started a left outer join chain. We just have to keep going with that. And that joins on the order IDs in both tables. So if I want to know the unique products each customer has purchased, I want to see the customer, which is the company name from customers, and I want to count the distinct product IDs in order details. This is the unique product count. And then I need to make sure to have my group by clause. So in this case, I want to see the count by customer. So company name is our customer. So I need to group by company name. So when I run this, I will see for each customer how many unique products they've ordered. And if I go down to FISA, I know they haven't made any orders, so they have no products. Same thing with Paris Specialties here. No products ordered. So another thing we could do with aggregate functions is calculate order totals and line totals. So let's talk about how order totals are calculated. We have our order details table. If we look at this, we've got unit price in this table, we've got quantity, and we've got discount. If we look at our products table, we also have a unit price in products. However, the unit price we want to use to calculate our order total is going to be the one in order details. This is what the product cost at the time that the order was made. This unit price here in products reflects the current price of the product. So, before we go to SQL on our order totals, let's discuss this in Excel and just mock up how do we actually calculate this order total. So we have an order. Let's say this is order 123. It was purchased today. Today is 2/26/17. It's our order date. And we have a number of items on our order. So we have item ID, we have the description, we have the retail price, what does it cost? We have the discount. In our database, discount is a percent. So I'm going to put that in percent. We have the discount amount that we could calculate. And then we have a quantity that the person ordered. And then we have what's called the line total. I have item 1. It is cheese. The retail price is $5. I had a 20% discount, so we can calculate that. And I bought 2 blocks of cheese. Item 2, this is going to be salami. Say my log of salami cost $10 because it's very large. There was a 10% discount on this, and I bought 3 of them. And item ID 3, what else goes good with this? Let's say I bought some beer. And since this is a specialty shop, my case of beer cost $15. And I got no discount on the beer. So I'm going to make sure that these are, yep, Excel knows their percents. And I only bought 1 case of beer. So in order to calculate my discount amount, I multiply my price times my discount. So $1 discount. Same for that. That means my actual price, or the price I pay, the discounted price. So that equals my retail price minus my discount amount. So then if I want to know how much I spent for all of the items I purchased of these. So for my 2 blocks of cheese, my 3 logs of salami, and my 1 case of beer. So I have to do some multiplication. It's my discounted price times the quantity that I purchased. I'm going to put some dollar signs on these. So $8 in cheese, $27 in salami, and $15 in beer. So these are my line totals. If I want to know what my order total is, I have to sum up my line totals. So that's, in Excel, the sum of all of these. I have to do equals, sorry. So for this order, I spent $50. Nice round numbers here. In SQL, we have to calculate the same thing. We have to take into account what was the original price, how much of a discount did the customer receive on each item, and how many of them did they order in order to calculate our line totals. From our line totals, we can get an order total. So let's go ahead and work on that. What is the total for order 10250? So I have to start by joining my tables. So in order to get order total, I could just start with the order details table if all I want to know is the total. But if I want to include the customer as well, I would have to join out 2 different tables. So for now, let's just keep it simple and work with order details, and we'll add that other information afterwards. So let's build what we have in Excel here. So the ID, we'll ignore the description right now because that would have to go to the products table. The price, the discount, let's build our discounted price, quantity, and our line total. So the product, od.product ID, the unit price, the discount, and the quantity. Those are the fields we have in order details. So 3 items on this order: our unit price, our discount, our quantity. So if we want to know how much did they pay after applying the discount, we have to do some math in here. So we have go to a new line here. Unit price times the discount. Discount amount and if I want to know my discounted price, so it would be my unit price minus this. Got my quantity. Now I gotta multiply by this to get my line total. So I'm going to take this, add some more parentheses, so this is how much I paid for each of these products on this order. This is my line total calculation. This is the long way to do it. The short way to do it is unit price times 1 minus the discount times the quantity. So both of those do the same thing. So use whichever calculation for line total makes the most sense to you. This is the one that's easy to figure out if you can't remember what the calculation is. This one I think is shorter if you're good with math. But either way, this will get you there. I'm generally going to use this calculation for line total. So this gives me all of my line totals for this order. In order to get my order total, I need to sum up this line total. I'm going to comment this one out. It's going to be the sum of my line total, which makes it no longer my line total, but my order total. I'm also going to group by the order ID. So if I do this, again, I'm going to start getting errors because I have a lot of columns here that are in my select clause that aren't in my aggregate function and aren't in my group by clause. So I'm going to actually remove them. We don't need all of this detail anymore. We've gotten our line total. We verified that that worked. So I'm going to delete this and just look at the order ID. Okay, so order ID 10250 is 1552.60. So we could have done this for more than one order, or we could do this for a customer as well. So if I want to know, let's take a look at what customer this order is for. So I have to join back to orders. This joins on the order IDs again. In this case, if I want to see the customer, which I do, I have to add that to my group by. So this is for the customer Hanar. So let's take a look at how much has this customer spent with us in total. That's going to be a very similar query. We still need to sum the line totals, but instead of grouping by the order ID like we did in this query, we will only need to group by the customer. I'm going to copy the majority of this query here, and we're going to change the where clause. So where the customer ID equals Hanar. And I need the same line total calculation, which is this. But if I just do this again, it's going to show me a total for all of the lines on every order. What I want to do is I want to sum this up again. That was the line total. If I want to know it by the customer, I want to group by the customer ID. And because I group by the customer ID, this becomes the customer total now. So they have spent almost $33,000 with Northwind Traders. So same calculation, same sum, same inner calculation, whether it's a line total, an order total, or a customer total, depends on my grouping. If I don't group at all, it's a line total. If I group by my order ID, so in this case I group by order and customer, but order is more granular. Customer has multiple orders, and I have one order here. That makes this an order total. In this case, I grouped it by just the customer. That makes this a customer total. So we got our group by clause there. If we want to limit something based on an aggregate function, we have to use our having clause. So the having clause functions very similarly to a where clause. It has some condition that has to be true. We can think of our having clause as a where clause for groups. So where limits the rows that come into our query. Having limits the groups. So when we have a bunch of clauses in our select statement, first the where clause is evaluated. So it's going to filter out individual records. Then the group by is going to happen, and then the having clause will happen and filter at the group level. So it's a little confusing to talk through. So let's do an example. So we have our customer Hanar. I'm going to take this, and I'm going to show all of their order totals. So to do that, I'm going to include the order ID and group by that order ID instead. And because I group by order ID, this is now the order total. So they have 14 orders, and here is the total of all of them. So if I want to know, or I want to see, show the orders for customer Hanar that are over $10,000, I'm going to start with this query. And based on my results, I have one order, 10981. This order is more than $10,000. It's $15,000. So it's the only one I should get back. So the first thing you might try to do is say, and this is greater than 10,000. Doesn't seem to throw any errors. So we're going to get a problem though. When I run this, it tells me an aggregate function may not appear in the where clause. Don't worry about a subquery at all, but first part, may not appear in the where clause. So okay. So let's try again. A lot of times when students see that, they say, okay, I'm just going to get rid of sum. Can't have an aggregate function, I'm going to get rid of it. So that does show me that, but what it's saying is somebody with a line total. So show me any orders with a line total over this, which may or may not be accurate. So if I drop this to over 1,000, I get 7. So if I run this again and I order by the order total, let's do descending so we get easy line numbers. if I look at 1,000 here, so if I run this one, gave me 7 orders supposedly over $1,000. But if I go back to all of my orders for this customer, and I look at things over 1,000, so we're sorted by order total, there are 9 that are 1,000 or more. So what this one actually does is this limits the line totals. So I'm going to change these so that this works better. Limits the line totals to more than $1,000. Two orders are missing. There should be 9, but we got 7. So what we actually want to do is use our having clause. The correct way to do it so having comes after group by. I want the sum of the order the sum of the line total, which is my order total, to be greater than $1,000. So if I run this, I get all 9. So when you want to restrict based on a column that is an aggregate function, it has to go in the having clause. And you have to include your aggregate function. So I've got my where, I've got my group by, and I've got my having here. And just for fun, to have our entire select statement with all the clauses, let's add an order by. So let's sort this highest to lowest. Okay. So there is our full select statement with all of our clauses. We've successfully limited this to orders over $1,000. We are doing good. However, if you are like me, it might bother you that my order total is not displaying correctly. It's got too many decimal points. So again, I'm going to cast this to a data type that can hold only 2 decimal points. So I've got 15,000, so that's 5 digits on that side of the decimal, plus 2 on the other, which means I need at least a numeric 7, 2. So 7 total digits, 2 on the left of the decimal. Oh, sorry, 2 to the right of the decimal. Missed a parenthesis there. And now it looks better. So, as you can see, we nested those functions. There are a couple things with nesting functions in SQL Server. So we can't nest aggregate functions inside of other aggregate functions. So I can't take the average of the sum of something. Doesn't work. If we want to do that, we'll have to wait until we learn subqueries. We can nest aggregate functions inside of scalar functions. So we did that here with our casting the result of our aggregate function. So I can cast the aggregate function there. I can put a scalar function inside of an aggregate function. So I could flip these around. That would work. Not in this scenario, but to have a scalar function inside of an aggregate function would work. I just can't have an aggregate function inside of another aggregate function. So let's do one more example with our having clause. So I want to know about customers who have less than 3 orders. I have to start with my customers in my orders table. And again, I'm going to left outer join or left join to orders because my customers might not have any orders and they should still be included. So these tables join on the customer IDs. So if I want to know customers with less than 3 orders, I have to know how many orders each customer placed. I want to pick the company name, and I want to count their orders. And I need to group by my customer in order to do that. So here's all my customers. Here's their count of orders. Just going to make sure that Paris is still here. They've got 0 orders. Same thing with FISA, 0 orders. If I want customers with less than 3, I need my having clause. So I want this count to be less than 3. And that shows me I have 6 customers with less than 3 orders. Some of them have no orders. So one other thing I want to talk about with count. This is the correct way to do this. So this does not work correctly. So if for some reason I had a left join in here to order details, we've got 6 people here. If I were to run this, now I have 4. So if we need to see what's going on here, we have to get rid of our having, and we actually have to get rid of our count as well. Yeah, let's leave that in. I'll just put the order ID. And I have to comment out my group by as well. So what happened here is all of a sudden we've got the same order ID listed multiple times. That's because when I join to order details, I get 1 record for each product on the order. So when I'm doing my counts, I have to be really careful to make sure that I don't have extra records in here. So this won't work as is. The best thing to do would be to remove order details. However, if for some reason you need to make this work, again, you could use distinct here. Count the distinct orders, having the distinct order count less than 3. That would work. So let's get rid of these so it shows you that it doesn't work. Best way to fix it would be to remove the join to order details. However, we can also fix it by using count distinct. So we will go over some more examples of this in class because I know this can be a very confusing topic. That is the end of our lecture, so I will see you in class and we will do some more examples.